Imagine a construction site sitting on top of a mountain so remote that reaching it alone feels impossible. No road, no crane assembly zone, no clear path for heavy machines. For decades, this kind of location meant one thing: construction becomes slow, expensive, and sometimes impossible. But now, something unusual is happening. Massive drones are lifting steel, concrete, and heavy equipment straight through the air, crossing cliffs, forests, and valleys, delivering material exactly where workers need it. No roads first, no heavy ground logistics, just air. And that changes everything. Because if materials can reach the site without touching the ground, then what exactly is stopping construction anymore? Online, this story went viral with a dramatic claim. Some videos suggest China is now using drones like flying cranes, lifting entire tower cranes and dropping them onto mountains. It sounds futuristic, but it is not true. No drone today can lift a fully assembled tower crane. The weight of its base, counterweights, and structure makes it impossible for aerial systems. So the real question becomes more interesting. If that viral image is wrong, what is actually happening? The truth is not about lifting bigger things. It is about breaking construction into smaller pieces and flying them one by one until the entire structure is built without traditional access. Not one massive lift, but hundreds of controlled air deliveries. And this shifts the entire logic of construction. In normal engineering projects, the hardest problem is not building the structure. It is reaching the structure. Before a single tower is built, teams must create roads, clear land, or build temporary transport systems. In forests, that means cutting paths. In mountains, that means carving access routes. In river valleys, that means building temporary bridges or cable systems. Often, weeks of work happen before actual construction begins. But heavy lift drones remove that first barrier completely, because now, the site is no longer something you travel to, it is something you directly supply from above. China has already started using multiple industrial drone systems for this shift. Machines like the Skytech S400 Plus are designed specifically for power grid construction. With multiple rotors working together, it can carry heavy components across terrain where vehicles cannot even enter. Then there is the United Aircraft TD-550D, built for high-altitude performance where thin air reduces lift for normal aircraft. Its coaxial design helps it stay stable in extreme environments. And DJI's flycart systems introduce something even more practical: winch-based delivery. Instead of landing, the drone lowers material precisely using controlled cables. That detail changes everything. Because construction is not just about carrying weight, it is about precision under pressure. A load must be lowered near workers, wires, or unstable rock surfaces without swinging or collision. At that point, the drone is no longer just transport. It becomes an aerial crane. One of the strongest real-world examples comes from Yunnan. In this region, engineers had to build high-voltage transmission towers across limestone mountains, dense protected forest, and an elephant migration corridor. A normal road-based approach would have destroyed the environment and taken weeks of preparation. So instead, drones took over the logistics. Across just 3 days, 16 heavy lift drones transported around 180 tons of steel and construction material directly to multiple remote tower points. Flight after flight, supply after supply, the mountain was built without being carved open. No roads first, no heavy ground disruption, just aerial delivery. But the real impact is not the number. It is what was avoided. No forests were cut for access. No heavy cable systems were installed just to begin work. The environment stayed largely untouched, and construction still happened. A similar shift appeared in Xinjiang. A transmission tower was located across unstable terrain and a river crossing. Normally, workers would carry tools manually through dangerous paths, taking hours just to reach the site. Instead, drones handled the entire transport mission in minutes. More importantly, they removed the riskiest part of the job: human travel through unsafe terrain. This is where the technology becomes powerful. Not replacing workers, but removing the most dangerous steps from their workflow. Then in Hubei, another challenge appeared. During winter, ice formed on transmission lines, making maintenance extremely dangerous. Ice adds weight, damages systems, and puts workers at serious risk. So drones were deployed again. One system delivered controlled heat to melt ice. Another used mechanical force to break it away from lines. It may look unusual at first glance, but the logic is simple. Send machines into danger zones and keep humans out. Across all these cases, a pattern becomes clear. Drones are not replacing construction systems. They are removing friction points. No need for access roads first. No need for dangerous manual transport. No need for workers to enter high-risk terrain just to begin a task. They are not changing what construction is. They are changing how it begins. But to understand why this matters globally, we need comparison, because years earlier, the United States already tested similar capability. The common K-MAX helicopter, later converted into an unmanned system, was used to supply remote military bases in difficult terrain. It proved one thing clearly: autonomous heavy lifting works. But it never became a large civilian system. The reason was not technology, it was scale. High cost, limited production, and lack of commercial integration stopped it from becoming part of everyday infrastructure. So the capability existed, but the ecosystem never expanded around it. China took a different route. Instead of building one advanced machine for rare missions, it built an entire system of smaller drones designed for repeated industrial use, especially in power grids, construction zones, and remote infrastructure projects. At the same time, airspace regulation and industrial planning began adapting to support drone operations as infrastructure, not experiments. That difference is critical, because technology alone does not scale. Systems do. Still, this future is not without limits. Heavy-lift drones face real challenges. Battery life restricts range. Strong winds affect stability. High altitude reduces payload capacity. And safety risks increase with heavier loads. They are powerful, but they are not replacements for large cranes in full-scale urban construction. But that is not the real shift. The real change happens earlier, when a project no longer needs a road before it begins, when forests are not cut just to start access, when mountains stop being barriers to entry. That is where economics change. That is where construction becomes possible in places that were once ignored. And that is why this story matters. Not because drones are replacing cranes, but because they are removing the need for cranes to always start the process on the ground. The next phase of infrastructure will not look like machines building skyscrapers in the sky. It will look far more subtle. A drone delivering steel to a mountain tower. A drone crossing a river with repair tools. A drone clearing ice from power lines before workers arrive. Construction will not become science fiction. It will become reachable. And if this system continues to scale, the biggest transformation will not happen in the sky. It will happen on the ground, where roads are no longer the first requirement for building the future.